Minecraft. The most frequently cloned video game. Except for maybe Flappy Bird. The core mechanics of Minecraft are simple enough that I was able to recreate it in just 24 hours using the Unity game engine. It has infinite procedurally generated terrain, caves, water, trees, even mining.
Wait, that's not actually Minecraft. There's no crafting or biomes or...
Like I was saying, it's pretty much exactly like Minecraft, which is actually a big problem, because cubes are pretty boring. Games like Astroneer, No Man's Sky, and many others generate procedural destructible terrain, but with no cubes in sight. Here's the new challenge. Figure out how these games work and convert my Minecraft clone into something with much more realistic terrain. It should be procedurally generated, infinite, and fully destructible. Let's start with the basic sine wave. If you really use your imagination, it sort of looks like some hills or something. So let's turn it into terrain. In order for it to actually be rendered by a game engine, we need to somehow convert it to a mesh made out of triangles. In 2D, we can accomplish this with an algorithm called marching squares. Marching squares will build up our mesh one piece at a time by checking how the terrain intersects with many small square-shaped regions. For our terrain generator, we'll use the 3D version of marching squares called, you guessed it, marching cubes. And instead of a sine function, we'll use some slightly more advanced coherent noise functions, which create much more natural looking hilly terrain. Alright, let's get programming. After reading through a bunch of articles, and maybe stealing a little code, I was able to get started on my own implementation. And after a few hours of work, we've got a pink rectangle. Alright, there we go. Here is marching cubes generating a mesh from 3D simplex noise. Yeah, I don't even understand. Now let's add this to the existing Minecraft world. The terrain generator works by splitting the world up into smaller pieces called chunks, which can be loaded in and out as the player moves around. So just swap out the blocky mesh generator for marching cubes, and it works without any problems. Okay, now we can walk around some procedurally generated terrain. So the blocks are definitely gone, but as you can tell, the terrain isn't really smooth. The solution to this is interpolation. Basically, we'll use some voxel data to estimate where the terrain intersects the edges of each marching cube, which will give a better approximation of the surface. So let's steal some more code, program that. And what the? Okay, something's not right. My code actually worked. Now the terrain is nice and smooth, but it's suspiciously smooth, and still doesn't look like real terrain. The solution? Fractal noise. Fractal noise just takes a bunch of noise layers of decreasing scales and adds them together, each contributing smaller and smaller details. And the result is much more natural looking terrain. Throw on a brand new grass texture and yeah, that looks pretty bad. But it's probably the most you can expect from me.
Level up with 555 fried and Spanish-style sardines. It's deliciously special.
Now let's add in some caves. Just like in the Minecraft clone, we'll use some 3D noise to cut pieces out of the terrain. But this time, the transition between the caves and the surface ended up being a little bit of a challenge because I had to deal with that whole interpolation thing. But I eventually sorta figured it out, and we've got caves again. Next, I added water chunks back in, which worked perfectly with the new terrain system, and slapped on that amazing stone texture. I unfortunately couldn't just reuse the tree generation code from the Minecraft clone. So what I ended up doing was taking a sphere and a cone and sort of combining them together. And trees. For terrain modification, I want to make something similar to Astroneer, where you dig these nice circular holes and build these big worm things. So what do we have to do? Just raycast and then increase or decrease the closest voxel values. Should be pretty easy, right? After a lot of tweaking, we've now got this cool little mining and building mechanic. Next, I played around with masking and transitioning between different noise layers, so now we can create larger scaled features like mountains and oceans. Finally, I made very high quality snow and sand textures, and the terrain generator is pretty much done. So you can explore procedural terrain and mine and build stuff, sorta. But like all my games, it doesn't look very good. I've been wanting to try out Unity's HD render pipeline, which will give your game AAA quality graphics with just a few clicks. Anyway, after 9 hours, countless pages of documentation, and 57 Google searches, I finally sorta understand how to use HDRP. Here's the final result. So this was Minecraft without blocks. And I guess without crafting. And pretty much everything else in Minecraft, except for like mining, I guess.
Good morning. Time to wake up. It's not e-
The GMTK Game Jam 2020. I'll have just 48 hours to make a complete game. The theme this year is
Out of control.
Alright, it's 3 o'clock on Friday. I'll need to come up with an idea fairly quickly because the jam time is just so short. After an hour of brainstorming, I've finally got it. Cellular Automata. If you don't know, a cellular automaton is a discrete model studied in automata theory. Here, I'll explain with an example. Conway's Game of Life. The game of life takes place on a grid of cells. Each cell can be in one of two states, dead or live. If a cell is live and less than 2 of its 8 neighbors are also alive, then it dies in the next generation. If it has 2 or 3 live neighbors, then it survives to the next generation. More than 3, and it dies. But a dead cell with exactly 3 live neighbors will become alive in the next generation. So you can set up some pattern and start the simulation to see what happens. Each generation of cells is calculated based on the previous one. Not impressed? Well, when arranged in certain configurations, new properties emerge from these simple rules. This becomes a glider that moves across the grid. This is a machine that builds gliders, called a glider gun. Look at this one. Conway's Game of Life is a 0-player game, meaning after the initial conditions are set, the simulation plays out based on the defined rules. For this jam, I want to make a game around this idea of cells interacting on a grid. The player will arrange them in some way, and once the simulation starts, everything is out of their control. In my game, there will be multiple types of cells with different functions. For example, a spinner cell will grab onto and spin cells around it. A pusher cell will, you guessed it, push other cells. The hope is that combining these different types of cells will lead to some kind of emergent properties as they interact. At around 4:30, I started up Unity and got to work. We've got a square, some scripts, but then I stopped. Yeah, so it's 9:30 now. All I managed to do in 6.5 hours is get a blue square moving across the screen. Along with some issues with the game concept itself, I just couldn't figure out how to program some of my ideas using the whole states and neighborhood stuff. So at this point, I decided to quit the jam. Just kidding. I eventually came up with a few ideas that would make this game possible. Then I drew out some level ideas and called it a night. To begin Saturday, I basically had to start the project from scratch, programming this free-moving cell idea. Okay, now we're 16 hours into the jam, and we've still just got a blue square moving across the screen. Next, I made some quick placeholder art for the mover, and gave cells the ability to have a direction. Now we have, are you ready? 2 blue squares moving across the screen. I'd say that's progress. The push cell basically does nothing, but it can be pushed by other cells. Just throw together a little code, and we can push one cell, or a stack of multiple cells. Cool. But now it's about to get a little more interesting. A generator cell will take the cell behind it and duplicate it to the front. So here it duplicates a push cell. If there's something in the way that can be pushed, then it just sort of pushes that and spawns the new cell. Let's add a mover cell that pushes the duplicated block out of the way. This is what happens. And we can even push a generator cell. One issue with the game right now is that it's kind of hard to tell what's actually happening because cells just immediately jump to their next positions for each step in the simulation. To fix this, let's add a little animation. And just like that, it's working. Oh, I guess not really. Okay, there we go. Alright, time for the enemy cell. This shouldn't be too hard, I hope. Each enemy will just store its position in the grid, and then after each simulation step, we'll just check if any other cell is in the same position. And if it is, we destroy the enemy cell and the cell that hit it. So if all enemies are destroyed, then you win the level. The simulations and stuff are cool, but I don't think a completely zero-player game would be very fun. So I implemented the ability to drag and drop cells into different grid positions so the player can control the starting state of the simulation. Next, I made some buttons that will let you play, pause, or step through the sim. Now it's 12:30. Somehow nothing's gone wrong today so far, so hopefully it stays that way. The rotator cell will work a little bit differently than my original idea. The rotator itself won't spin, but it will rotate the cells next to it and not affect their positions. So it can alter the trajectory of mover cells and just sort of spin around other cells. If there are two rotate blocks next to a cell, then it will spin 180 degrees. Okay, this one just can't be moved at all. Similar to a push cell, a slide cell can be pushed, but only in its indicated direction. Just like this. Oh, not like that. Like this. It can be useful for doing things like temporarily stopping movers. Now we'll add in some level navigation. We've got a button that will pop up once you complete the level, and it will just reload the game scene with the next level. But for some reason it's not working. Oh wait, maybe it's because I haven't actually made any levels yet. Let's fix that. Wow, so challenging. But don't worry, these are just the first levels to introduce the different cell types. Now I can start making some that are a little bit more tricky. At this point, even for my already low art standards, the game looks terrible. For some reason, I decided that I would do pixel art for this game. The problem with this is that I've never really made pixel art before. I mean, I've never made anything that can be considered art. So I guess this won't be much different. I think you're supposed to do like a random pattern for shading or something. Yeah, I don't really know what I'm doing here. Okay, along with the dark background, I think that's at least better than what we had. Alright, let's make some more. Alright, we definitely need some more levels. Here's a few I came up with. In this level, you have a few generators. Maybe an earlier point in the video gives a hint to that one. Maybe. In this one, there's a little moving, rotating machine thing that prevents you from taking a straight shot at the enemy. So you'll have to figure out a way to navigate around that. This is my absolute favorite level, which I'm going to save for the very end of the game. You only have 4 generators and have to destroy all these enemies down here around 2 corners. The game still needs a lot more levels, but I want to start adding some polishy stuff now in case I run out of time, which is likely to happen. I first added some post-processing, hoping it would somewhat hide my terrible pixel art. Then I found a font and started generating some sound effects. Title screen? Done. More levels? Done. A tutorial? Sure. Enemy explosion particle? Of course. Level select menu? Not quite. I started on it, but at this point I'd been working on the game for like 17 hours, so decided to call it and go to sleep. Alright, it's submission day. The first priority is to finish up that level select screen. And the game still needs more levels. I kind of just built random stuff to see if anything interesting would happen. I ended up making 3 more levels, bringing the total up to 17. Hopefully that's enough. I don't have too much time to make music, so I just used my normal technique of placing some notes completely randomly. Alright, 4 hours to go, and the game is pretty much done. It could probably use some more stuff, and definitely some bug fixes. But for now I'm going to do a build, get the itch.io page ready, and submit the game to the jam. And the game is submitted. Okay, I should probably get some sleep. Or I can just stare at the countdown and worry that my game isn't submitted correctly, or has some game-breaking bug. Yeah, let's go with that second option.